Hey, hey. Well, it's DJ Glenmo again, back here in the Smart Energy Lab with a guest. So thanks everyone for turning up for another Toolbox Tech Talk. And my guest today is Cameron Lynch, the Area Sales Manager for Australasia. That means it includes you guys in New Zealand, which is kind of cool, for DEIF. Now, DEIF is Denmark Electro Instrumentation Factory. So, Cameron, welcome.
Yeah, thanks for having me, Glenn. Appreciate it.
Let's start with a bit about the company's history. Obviously, it comes from Denmark.
Yeah, so obviously it has the name Denmark Electro Instrumentation Factory. It's a 90-year-old company, founded back in 1933. It is a family-owned business by Torger Foss. The current owner was founded by his father, Erling Foss, obviously back then, and hence the name, the Electro Instrumentation Factory. Back in 1933, there wasn't any electronics, so it was more instrumentation and whatnot. So head office is in Skive in Denmark, when we're across about 12 subsidiaries globally, and I think 600 employees internationally, with 20% of our employees in Skive in R&D.
Wow. Okay, so instrumentation through to what? What's happening now with DEIF?
So we sort of progressed from instrumentation right through into, you'd sort of say, reciprocating engine controls in marine and land, with about an 80-20% mix. So 80% of it in marine controls. But with the integration of renewables, solar and BESS, we're now looking at about a 50-50 mix with marine and land-based. So the company currently, our main sort of focus would be an EMS PMS controller offer, where we offer one specific product that will do mains control and protection, also PV in the way of inverter control, battery energy storage, wind, hydro, and as well as also ATS and bus tie control as well.
Whoa. That's a whole lot of acronyms. So what's EMS?
So EMS stands for Energy Management System.
And PMS?
Power Management System.
Oh, okay, good. It's not a medical condition.
No, it's not.
So, yeah, what are some of the milestones for DEIF? You know, you started in 1933, which is amazing. Nearly 100 years old now. It's still a family business, and progressed from just the marine environment. What are some of the steps in the history of the company?
So I suppose, Glenn, one of the main sort of factors of, because we started in the marine's a very controlled sort of environment with the standards with Lloyd's, DNV and whatnot. And I suppose that's sort of ingrained in the DEIF DNA, where we've now progressed into land applications where solar, battery, energy storage, and renewables, it's a forever changing sort of market with technology growing. So we utilise that marine focus of being very focused on safety and energy, with a more of a integration into land as well. So.
Right. So, yeah, basically renewables have thrown in a whole new sort of market for you.
Yeah, 100%.
Yeah.
Definitely.
So integration of rotating machines and renewable energy systems like inverters and batteries.
Yeah, correct.
So hence the EMS. We'll get onto that in a bit later, because we actually have two guests here today. I've got Jacob. I'll introduce him in a minute, but we're just going to talk a bit more generally to start with about DEIF. And so a little bit more about, how does DEIF's background in traditional genset and marine systems influence your approach to hybrid and microgrid applications?
So as I said, DEIF, we've been around for 90 years in the marine side of things. Here in Australia, we're only quite new into the market, with sort of the employment of our first local employee only within the last 2 years. And we've actually grown into probably a workforce of 8 nationally now, and just opened our first office in Notting Hill in Melbourne as a training facility, where we also offer support, technical support and whatnot too, through a support engineer and also applications engineers. So
I'm trying to actually picture the product here. I know what it looks like, but I mean, we were talking about something that is a component in a bigger system. Is that correct?
Yeah, it's a controller in the way that you could probably call it a microprocessor controller, where it's got various inputs and outputs. And that one controller can be used for several different applications, whether you just want to control a diesel genset, if you just want to control a battery energy storage system, modulation through inverter control, and also monitoring of mains and whatnot. And those controllers all talk to each other through either Modbus, Ethernet, or CAN bus system to be able to integrate together.
Wow. Look, I've got a little self-disclosure here. I really come from the small end of town in terms of renewables, so residential and a little bit of CNI. And I was just thinking back to like 2010 when I did a 20 kilowatt PV system. I thought that was really big. But you deal with much bigger stuff than that.
Yeah, look, you'd sort of say it was more sort of focused towards the CNI space, the larger commercial, right through to we sort of draw the line at that 5 meg mark. But we do also, like globally, we've got the capacity to go well over that. So,
and in terms of EMS, once again, the term energy management system, I kind of just got used to the fact that most, small scale inverters, residential and CNI, actually have effectively that built into the product, but it's only in that one product. But you've got a separate device that can perform that function across a whole range of products and integrate them with communication.
That's correct. Yep. Yes.
So you're a systems agnostic to some extent.
Yeah, for sure.
Right.
I mean, we can utilise our controllers to whether you're looking at different brands of batteries and different types of inverters, both greenfield and brownfield sites, where you've got third-party controls as well too that need to be integrated. We've also got the ability to do that with our controls.
Right. So how does DEIF support system integrators and installers during commissioning and ongoing maintenance?
So so DEIF here in Australia, obviously quite a new presence locally, where we actually employ systems integrators out of our Melbourne office and also applications engineers. So we've also developed a system integrator network of preferred companies that we're still currently growing, where we can actually make recommendations to assist with projects and utilising our team sort of back at head office in Denmark as well as out of Shanghai, where we've got, just out of Shanghai, we've got, I think, 7 land-based engineers that'll assist our customers with the programming, the integration, and even the design of systems.
So a lot of it can be done remotely.
Yeah, correct.
So your engineers can basically log into the equipment and configure, fault find, etc.
Yeah.
Do you offer local support like at the site?
We do, especially with battery energy storage systems. We do a lot of factory acceptance testing. So, and we've had applications where out of China where we've sent members of our Chinese team out to do the factory acceptance testing. The units are then sent to site, where we have our local support engineer goes to site and does the site acceptance testing, and also assists with the commissioning through commissioning assistance for those customers as well.
What's the benefit of acceptance testing? Why do you do it?
It's sort of acceptance testing in the way is it ensures everything's going to work correctly once it gets to site. One of the other benefits through our system and the programming of it, we have the ability to run it in emulation mode. So we do a single line where we then upload that to the controller. It's a multi-master system. So in the way that if any point in time one of those controllers or one of those elements or assets is removed, the system will then reassess and readjust on how it works. So by running it in emulation, we can sort of see any unforeseens through the design of it to ensure that it's going to operate 100% efficiently by the time it's sent to commissioned and handed over.
Right, it saves any embarrassment on the day. You solve all the problems virtually and then upload that to the device. Yeah,
it's easier to sort it out in the office than it is out on site.
That's pretty cool.
In a remote location.
I guess you can do sort of what if scenarios too. Like, what if we do this? How will it work?
Yeah, so through the emulation side of it, you can set it up so if someone comes along and turns off the main switch or turns off the unit or the battery goes flat or there's no sun, you can run those scenarios to see in live time how that system is actually going to work.
Oh, wow. That's pretty cool. So what kind of training or digital tools did DEIF offer their partners and engineers when deploying their systems?
So part of our first office setup here in Australia in Melbourne, we've got a 12-person training room. We sort of generally offer training for system integrators or anyone that's interested at quarterly, where we bring our trainer down from Singapore and he delivers it sort of in the control side of things with either diesel genset focus or renewable focus, also in the way of our touchscreens and our more advanced controllers as well too. So offering that local training for customers that require it is also something that we offer locally.
Yeah, cool. Do you have any online training as well?
It is something we are looking into. We do some stuff over out of Denmark and out of our other subsidiaries, but we probably will do more localized online trainings here in the near future.
So say you've got a systems engineer, how long would it take them to come up to speed to use one of your products?
Generally, as I said before, our core product, the ASC 150 or AGC 150, it's a one-day training course, and that takes you right across the actual installation of the product, the programming, running it in emulation, fault finding, that kind of thing, and setting up the different parameters within it.
So do you have like a test system, not just emulation, but like you can actually demonstrate it working?
You can demonstrate it working through just one controller. So if you've got multiple controllers in an installation, so long as you've got one controller to hook up to, you can run that emulation. Locally in Melbourne, we do have emulation panels and touchscreens that are set up as systems. So we can actually we can set that up on our proprietary controllers in the office and assist there and bring customers in to demonstrate on how that's going to work too.
All right, like a virtual battery, a virtual generator.
Correct.
Yeah,
correct.
And the grid. Oh, wow. That's cool. Hey, I think we're going to bring in Jacob in a minute and do a bit more deep diving into the tech stuff. But thanks, Cameron. Thanks very much for dropping in on Toolbox TechTalk.
Yeah, thank you.
Okay. Next up is Jacob. Well, welcome, Jacob.
Thank you so much.
So Jacob Danielsen, he's the product manager for new technology and storage at DEIF. Jacob, you've come all the way from Denmark.
Yeah, quite far.
What did you come for?
Definitely to support the Australian team, but we also have a great event next week where we are celebrating the office opening in Melbourne. And beside that, we see a lot of renewables or sustainable activities here in the area. So to feel and touch what is going on, what are the challenges for the Australian customers. It's important to be here face to face.
Yeah.
And of course, All Energy, the exhibition, I believe you will be there as well, is also a great event to actually get that feel and touch what is going on.
Yeah, you really kind of get to meet the boots and the suits and the competition.
At the same time, yeah.
That's right. Yeah. So let's talk a bit about reliability and redundancy with your systems. They're all about, a lot of them are critical operational systems.
Absolutely.
And so how do you sort of manage reliability and how do you ensure redundancy and fault tolerance?
Yeah. Just as Cameron talked about, DEIF is having its roots in the marine. And I think everybody can understand that if you are on a ship in the middle of the ocean, you don't want to lose power. And that is actually kind of our DNA. We all our platforms we have developed over the last, I would say, 3-4 decades have been, you can say, with the focus on reliability. And so all our controllers and so on are like a distributed system. So if one fails, then another one will take over.
Oh.
And that they will actually independently do the job, you can say. So that is, of course, also something we have transferred into the land business, also with the renewables and so on. I think we are probably one of the only, let's call it hybrid systems, where we have a controller for each asset. And that can be good, it can be bad. We sometimes are challenged that people say we sell too much hardware, but it also gives you you can say, a system where you can focus on each asset and then put them together. I'm from Denmark, and maybe people don't know that Lego, the toys, are actually also from Denmark.
Everyone knows Lego, yeah.
And we very often say it's a little bit like this. We have made the system that you can make it piece by piece, and you can form the functionality you need. So that is what we have tried to do. Yeah.
Lego EMS, I like it.
Yeah. And And redundancy and all of this is actually, you can say, again, a part of the system from the very beginning. We can do redundant controllers if it's needed for bigger sites where reliability and other things is needed. But also, as I said, the multi-master part is actually already from our very low-level platforms. So you get that more or less for free.
Actually, when I think about it, marine is more than just off-grid, it's off-land. And as you say, it's much more critical. You know, if you're off-grid and you lose power, you can go to your neighbour's house and have a drink of water and borrow a cup of tea or something. But if you're out in the ocean and you lose power, you're adrift.
You're in deep trouble, yeah.
You're in deep trouble.
Yeah.
So paint me a picture of these assets and what they might look like. So a typical situation where you have multiple controllers.
Yeah. If you look at where we are coming from, then it's also very fossil fuel, diesel driven, kind of, you can say, 40 years ago on a ship, there was nothing beside diesel or heavy fuel or whatever. So when you look at diesel generators today, you always have a small unit to start and stop the unit. And nowadays, just like in our cars, there is a CAN bus communication to what they call a ECU, engine control unit. And you can say these controllers, they are connected to that ECU to get motor temperatures, speeds, other things. So we are sure that the physical device running our power or generating the power is okay. And we have actually taken that mindset to all the other assets as well. So if you take a PV installation where one controller can connect up to 32 inverters, then we also communicate with the inverters. Of course, one of the important things is to be able to control the power output from the inverters. Just a simple functionality called minimum genset load. When you make the combination of one diesel genset and one PV, then many think that let's just let the solar produce all the power it can, and then the genset will, you can say, just follow or make sure that it's running fine. But everybody who knows a little bit about a car or a diesel generator know that it's dangerous to run it in too low load. I normally say it will be like taking your car and put it into fourth, fifth gear and then only run 20 kilometers per hour. It will not run very smooth. So our system, even though we have two controllers, one for the PV, one for the diesel genset, we absolutely make sure that both assets are in the sweet spot, or at least at a level where it runs in a nice way, and we don't destroy one or the other asset. And and we can continue to fuel cells, batteries, and other things, how we actually, you can say, benefit from the nature of the different assets. And that's actually one of the great things we are doing at the moment.
It's interesting you gave that example, because I actually had a question from a former student who's got a farmer as a client who has a diesel-powered pump, and he wanted to reduce the cost of diesel, so he thought he'd just put on a PV system to displace as much of the generator as possible. But he hadn't considered the low load issue, and that there's actually a very great fuel inefficiency in that too, not just reliability. So, but you can keep it in the sweet spot. So
exactly.
Reduce the amount of non-renewables, but still in a safe way.
Yeah, absolutely. And you can say that is actually, the PV is more like you might curtail power to keep the genset running at a certain load. And then again here we move into the battery part, where the batteries coming into the renewables, or even the combination of battery and genset is amazing. It's we have customers who have, you can say, we also do a lot of rental customers, where it can be a golf tournament or Formula One in Melbourne or whatever, where they bring in extra power. It can be for the television transmission or other things. And earlier, when they did the calculation for a event, then they looked at the peak power, and then they maybe added an extra 20-30% to make sure that they covered it. But it was all done by maybe smaller and bigger gensets, diesel gensets. Now to bring in a battery in that equation actually helps that you can say you can lower the size of the diesel gensets independent on when the peak load is during the event and so on. You can actually plan to make sure your battery is fully charged to support the diesel genset. But what our controllers are easy to do is not to run at minimum load, but actually bring the genset up to an optimal load point. So instead of running the car in fifth gear, 20 kilometers per hour, we would like to run it at 100. Because here we know that it's the most efficient, it's less polluting, and all of this actually is you can say a great combination. And we have customers who have saved around 30% of fuel on these events, just the combination of diesel gensets and battery. And the funny thing is that there's nothing green in it, but it actually is quite efficient.
Yeah, I'm very familiar with that scenario for off-grid because, like you say, running a diesel at its optimum load is the most fuel efficient. Therefore, you're saving in terms of emissions and cost. And a battery allows you to have another load. So you've got the customer's load, and then you've got the battery as a load, and your controller can choose how that energy is dispersed so that there's always a constant load on the generator.
Yeah.
Yeah. So, and I guess you can also go, if you have a big enough inverter, quiet time too. You can, like it might be after the event, but they still need power. You just ramp down the generator and you're running off a battery.
Exactly. That is also a standard feature in our systems is to, you can put in the priorities and you can say, okay, do my battery have the first priority or highest priority? Then we will, you can say, take energy from the battery first. But at the same time, we will maintain the gensets if they are running. And then very often when we talk to customers, we look at, you can say, 1 day of the event or whatever. And if it's a rock concert, many people think that, okay, the peak load is around maybe the biggest concert or whatever. But it's not the truth. It's when we are going to have some food, the pizzas or sausages or whatever, then actually the peak load is there. So again, if you can predict it, and that is where the energy management come into the picture, then you can actually prepare for that situation and then actually save a lot of fuel.
Yeah, it's understanding those peaks. I mean, I remember hearing that the UK Power Authority used to have a television so they could see when Coronation Street would come on. The days when everyone used to watch it at the same time because everyone would put the kettle on.
Exactly.
So you got to know what those peaks are. But I guess you can also use that battery to support that generator when there is a peak flowing through. So you don't have to size the generating system so big.
Yeah, we see that a lot in construction areas and so on. Also, we see construction industry going where the excavators, a lot of other tools and whatever is going electric. So you're absolutely right that when we look again 24 hours of a construction site, then we during nighttime when maybe there's a few people sleeping in at the construction site or whatever, then you can just run on battery and it's quiet and people can sleep and it's very interesting, but also challenging because I know from some of your other interviews and podcasts that there has been a talk about inertia, how to balance between the thermal machines or the rotating machines and then power electronics coming in from the battery part. And that is also, just to be honest, some of the biggest challenges we have for our customers, because when you look at a system, if you buy a battery for your you can say application or your site, then very often the funny thing is that we are the last one to come into the picture, because we are not that expensive. So we very often see that the battery containers or battery systems have been chosen because they are the most expensive one. The next expensive piece is the power converter, and then we come as the last part to do the magic on top. And we very often see that it's getting better, but we very often see that the choice of power converter are actually not fully good to operate together with a genset in parallel operation and so on. And that is where things like our team in China, they are really good to help to clarify these, you can say, challenges, and maybe as early as possible try to say, can it do the job or can it not? Do we need to choose another power converter to actually do it? So, and I can see around here you have a lot of nice things. So I believe we could also go around and say which one could run parallel with a genset or not. And there will probably be around 30% that can do it in a good way. And maybe 30% say they can but can't, and the rest is honest and saying we can't.
Right. So you have to learn a lot about those power converters and understand their functionality and features.
Yeah.
I've got a question for you. So I've recently learned about droop mode.
Yes.
And I didn't really know much about this, that when you're sort of AC coupling a grid forming system with another inverter system,
Yeah.
Some have this ability, it's called droop mode. Now, what is that?
Yeah. The droop mode is actually a kind of thing coming from the diesel gensets. And you can say when you parallel a lot of the diesel gensets and they are providing power to the same bus bar, then whenever you have a load change, it can be up or down, then you actually want all the assets or all the diesel gensets to actually follow each other. And if you look at power management system or energy management system like DEIF, then we very often have a communication delay, between the measurements that we do of the power, and then when we give the command to change maybe the speed of the generator or whatever. So I normally say that we have the slow regulation, the slow control of it. And that can be between, I'm normally saying between half to 1 second. But inside many of these diesel gensets, there are a droop functionality, meaning that they actually can sense that if the frequency, which on a rotating machine is the RPM, is dropping, then it's maybe because a load is coming up. And then they know instantly that if the RPMs are dropping, then we need to put a little more on the pedal. So if we bring the frequency up, and in a system, you don't want only one to do that. You want all the assets to support that. And that is also a thing that's coming into the batteries. So you actually, at the same time as you try to make sure that, again, let's imagine that you have 2 gensets at a site and you actually want to save fuel or you want to do it in a different way. So you remove one of the gensets and put in a battery. Then you want, the same functionality as I described before. And if the battery don't support that instant load support or droop curve that is inside the power converter, then you will see that the genset is taking all the impact of the load change, and the battery will wait until it gets a command from our power management system, and that will be a second later. So you actually start to have a unstable system, or it can be unstable. So what they are doing in the power converters is that they actually put in a droop curve, and it's typically an offset from a frequency. So also the power converter now it doesn't have the RPM like the diesel genset have, but it has the frequency as a nominal. So if suddenly it sees the frequency dropping, then it knows instantly that I need to contribute with a certain margin of extra power. So I actually support the diesel genset or the battery next to me to actually. So I very often say it's a little bit like, again, driving your car, or if you are two guys on a bike and it's the same bike. I don't know what the English word is for it.
Tandem.
Tandem, yeah. And you can say one guy is reacting slower than the other when you are going uphill. Then the first guy have to take a lot more power in his legs than the slow guy. And that's a little bit the same here.
So droop mode is making sure the guy on the back actually is pedaling properly.
Exactly.
When that hill comes. Oh, wow. Okay. So the droop mode is actually in the power converter.
Yeah.
Because it can respond very fast because it's actually watching the frequency.
Yes.
It doesn't need comms.
No.
Yeah.
And the whole idea is, of course, that the instant impact, it helps each other. And then if we want to, you can say, differentiate the power after the impact have come, then we are coming as the slow regulation and say, you are taking too much power or whatever. And then we are bringing the power set point down. But it still follows the droop curve. So,
if you have two rotating machines, can you parallel them both on the same output?
Yeah,
Yep.
Normally you can. Yeah.
So you manage synchronization through an ATS or something?
That is actually built into many of our controllers.
Mm-hmm.
So we have always 2 times 3 phase voltage measurements, so we can do the sync check across a breaker, and then so that is standard in more or less all our products.
So you can control multiple assets to appear as one.
Yeah.
By controlling the synchronization and their load contribution.
Exactly.
Yeah, right.
Yeah. We use that a lot when you, for example, are utility connected, but you want to disconnect the utility for a certain time, or there's maybe a failure, like there can be many reasons why you want to disconnect. And then when you not need to bring the whole site back into sync with the mains, then actually we use that functionality as well.
Actually, that's a really good segue to my next question, which is I've been thinking a lot about AI lately because I've been playing with it and thinking about data centers and the fact that, there's going to be already is a huge growth in data centers. But when it comes to data centers, they have to be 100% uptime, right?
Yeah.
Can you manage that kind of zero downtime?
We can, and again, that I think that again always have been in our DNA for coming all the way from marine, that we have 100% uptime. And one of the funny situations we have right now is actually that there is a lot of you can say activities in data centers right now, especially for the AI servers and so on coming into the picture. But even though China is a very competitive country and so on, we are actually the number one EMS or power management system to be built into the Chinese data centers. I think right now we have around 80-90% of the market in China, and who should know that? But again, that is where I think our history of you can say proven record of different installations, data centers, we have done them the last 20 years, come into play. And whenever things need to go fast and you want some of the best on the market, then it pays off now. So I think one of the challenges we hear about in data centers is, of course, that the new servers, that they also have high peak loads. many people, also young people, I don't think they understand that whenever they send a ChatGPT command or whatever, what happens with the energy in the data center. It sometimes peaks 10 times higher than a normal activity on the internet and so on. So, of course, there are new challenges, and I don't have the answer to all of it, but we are getting there, and we are already, of course, heavily installed in data centers, but we also try to see how we can, you can say, support with other products, and we are actually looking from DEIF point of view. We are working on our own power converters as well, so we actually try to bring in, you can say, our knowledge from energy power management, and then see how it combines best with power converter technology.
So to achieve true zero downtime, you have to have no transitions. So there's no milliseconds of no power. So do you do that by having multiple assets online at the same time? So if any one of them drops?
Yeah.
Yep.
You can say that one of the ways we in our system try to handle zero downtime is, of course, that you have a kind of reserve in the system. And that also helps when we talk about renewables, where you have maybe a little more unstable, if it's wind and PV, you cannot rely on that all the time. So here we either buy diesel gensets, have a certain amount of spinning reserve, as we call it, running in the background. We still make sure that it's running at least at the minimum genset load, but it's running actually waiting, ready to support it. And we also have some very fast startup procedures in some of our systems, where you can say that you can maybe take the first impact with a battery, or there's also very old systems like flywheel principles and other things. And then in that 30, 60, maybe seconds time, you very quickly start up many megawatts of diesel to actually support the load. So there are many different ways you can do it.
Right. So a battery with a power converter is the bridge between the prime mover when there's an outage. And so there's no loss of power.
It can be, yeah.
Yeah, right.
Yeah.
Cool. So how does DEIF test or simulate system resilience under failure condition?
We, you can say, I think it was touched a little bit before, that we have this emulation features. What I think also is a little unique is that way that we are able to download the full application to each controller, so it knows exactly where in the system am I placed, what are my neighbor capabilities, and so on. So that is one of the things that is unique about the DEIF system. How we test and simulate it, we again from a marine point of view, we actually do a lot of tests, and we also know that our hardware is some of, you can say, really tested down to, because we don't know where our hardware will end up. If we knew it would be here in a nice electrical panel, never exceeding 40 degrees and low humidity and other things, then it would be easier for us to make our products. But we never know if it will end up in a mine in Africa, or here in Australia, or here in nice high humidity. We know that is also possible here in Australia. So we have a test lab where we do the hardware testing deeply. On the layer on top, we also test our software to see, because with more and more processor power, you also need to make sure that the software in combination with the hardware is good. So that is one way we are securing that what we deliver to our customers. But we also have complete ships and complete sites built up with a crazy lot of wires and controllers at our facilities, where we have witness tests. It can be the authority companies coming, DNV, LR, but it can also be customers who say, I want to see the operation, and they have made, I normally call it a recipe or whatever, but they have specified maybe 30 different scenarios, and we need to show that it is able to handle that part. The challenging part is, of course, that the dynamics of a diesel genset or a battery or other things, that is sometimes hard to fully test in an office area or in a factory area. That is more when you know how the site is you can say running, or how is the battery acting when you are on site. So there are things we can't do before we are on site, but we support it. Yeah.
And you've got many sites which you've got experience from. So I know you can integrate with lots of energy sources. Can you integrate with wind as well?
Yeah, we can. I know here in Australia you have Vestas turbines. You have also Ned Micon in New Zealand, and again we are very proud coming out of Denmark of our wind turbines and wind history. So actually back in 2004, 5-ish, there was a lot of companies who merged together. That was actually when there's companies like Windworld and Gaia Wind, a lot of you can say smaller wind companies. They were acquired by the big ones, and there was actually also a lot of smaller installation companies, electricians, other things, who was a little left out in that equation. And at that time, DEIF acquired a small company called West Control, who was doing you can say wind turbine related panels and controls. And from there, we actually ever since have had a wind team, or we even had a wind division a few years back, where we did full control systems for wind turbines. Nowadays, in 2020, it was sold to one of the biggest wind turbine companies called Goldwind. Most of the activities there, but now we are doing refurbishment or retrofits of older wind turbines. So if a guy here or a farmer in Australia have an old Vestas V47 or something like that, and he feels that the mechanics are actually okay, but the electronics starts to fail, then we are able to do a fully refurbishment of that turbine, and actually also bring it in to our power management, so it can work together with diesels, PV, or whatever is needed. So we focus a lot on that, and I will also be honest and say it's not something we are getting gold to our pockets, but it's actually our owner. He has a extreme green mindset. So he actually invests in, you can say, CO2 reduction. And as we say, one of the greenest thing you can do is actually to keep a green machine running. So instead of scrapping a old wind turbine, where as I said, the mechanical parts are actually okay to go for another 5-10 years. Maybe a bearing has to be changed or a pump, but then it will continue and it has been paid 10 years ago. So the small investment to bring a wind turbine running for the next 5-10 years from a DEIF control point of view is almost a no-brainer. You should do it.
I've actually got some personal experience with this because I'm from Wellington, New Zealand, and maybe 15 years ago they put up a test turbine on top of Brooklyn Hill at the back of the city, and in a suburban area, like there's houses within 50 metres. It's right in the middle of suburbia. It wasn't a huge tower. It's probably like 40, 50 metres, but it's got pretty big. It ran for 13 years, and the company said they were going to take it down because it had done the testing they required, there was an uproar from the community. We want to keep our wind turbine. So they did what you said. They did a refurbish and put it back again.
Perfect. Yeah, that's really good. But that is also one of the parts we do.
Right. Okay. Well, I'm really personally very interested in microgrids, and so what can you give an example of how DEIF can benefit helping a microgrid function?
You can say again we build on platforms, and we sometimes say that we are a hardware selling company, and the software is a enabler. So what we have seen by the development from our customers is, of course, that it started maybe back in 2012, where some of our diesel customers came and said, we want to add solar to save fuel, and then it developed from there. So what we have done is to actually take the same mindset and say, whenever you add a new asset to your microgrid, so wherever you start, if you start with solar, it's fine. If you start with diesel genset and go in the other direction, it's fine. And what we have tried to do is to make it simple for our customers, because they buy one controller, put it on top of that asset, and then you can say configure it to say, today you are going to work as a solar inverter or a solar controller. You can take another one and put it on the genset or the mains connection or whatever, but it's the same hardware, same software. So whenever we know that a very few customers are able to invest everything the same day and know exactly where they want to be in 5 years. So what we have tried to do is, of course, that make our system flexible and scalable. And we also know, unfortunately, that all are not DEIF in the world. We would love to be, but it of course it includes a lot of our competitors' products and so on. But actually, the same product is able to adapt to whatever our competitors' products are, and
you can work with them. So they might have another brand controlling the generator.
Exactly.
Right.
So and that's the flexibility we have tried to build in, because, of course, we would like to make sure that people can use our great knowledge and features without considering a huge investment or a huge reinstallation of things or whatever. So that is one of the parts I think is provided to microgrid owners like you are. And then, of course, we also try to remove a lot of risk to do a lot of cooperation with the Chinese. And then I know here from the beginning of the talks that you and Cameron talked about PMS versus EMS. I will be honest and say 9 or 8 out of 10 customers I see, they are easily operating with a PMS system, meaning that they don't need to predict that tomorrow the sun is shining so and so much, because the dimensions of the system is that you actually utilize as much as possible with your load, with your you can say setup, and then you don't need all these predictions. It's more like when you want to make sure that you can participate in maybe trading or start to do a little more business with your system, then of course you need a more energy management kind of vision. But by the end of the day, many can actually, especially when it's microgrids where you are not connected to utility, then you actually have a full functional system just by making sure that power is available as much as you need. Not that you can predict tomorrow the wind is higher or whatever.
Well, I can give you a problem we actually have here at the Smart Energy Lab, which is because I call it the accidental microgrid because it was never designed as such and it just grew into one. Story of my life. So we have a grid forming system, which is a 45 kilowatt three-phase system with a 150 kilowatt hour battery, and it's using frequency shift power control to control the surplus or the control solar that is AC coupled to it. And
Yes.
there's lots of houses. We've got 7 homes plus some other buildings with solar on it. So it'll shift the frequency when that battery is full, and that's based on our standard 4777 Part 2, which
Yes.
tells you have to sort of reduce your output of your solar as the frequency goes up. But we also have added a very big AC coupled battery, an 800 kilowatt hour battery with a 50 kilowatt inverter. Now the problem is I have to run around constantly adjusting the settings so that the microgrid doesn't get full, so that curtailment doesn't occur on the whole system, because the big battery wants to keep going too and supplying the loads.
Yeah.
So I've got 2 systems that are independent that are kind of fighting each other.
Yeah.
I need that sort of synchronization across them. So is that something that DEIF can work with?
Definitely. You can say that is in our controllers. We have a lot of interfaces to different battery systems, and of course, we need to look into either protocol or other things that might be missing for your system, and then we can develop it, test it, whatever is needed. But what you would probably do with a DEIF system is that you buy 2 controllers, you add one on each battery, and then you connect them by either Ethernet or CAN bus communication. And then they will form a small, you can say, power management system between them. And they will know exactly, okay, one battery is maybe 40% SOC, the other is 80%, and then they will actually balance again to make sure that we are not overcharging or we are not, and then interesting is that frequency shift functionality. We have also done a few projects with that, and it was also not to call this remote, but Denmark is pretty much connected to Greenland, as some people know.
So far.
So far, there's the other mindset around the world that would change that. But we also have done some projects in Greenland where, as you probably know, during summertime the sun never goes down, and during winter it never comes up. And here you have similar that a small village, or a bygd, it's called in Danish, where there's PV on all the small houses, and then you have a central big diesel genset, and they have also removed many of these small villages. They had also a small fish factory connected to them. So whenever, but many of them have been shut down now. So actually you have a huge diesel generator to cover a small households of 100 houses or something like that. So here, many of it's actually government supported that you put in a battery, and again here it needs a lot of it needs the diesel to run during winter time, but during summertime it's actually difficult to handle all the power coming in. So we have projects quite similar to your challenges here, and it works quite well. But again, you of course you need to adapt to the season of year or whatever. I believe you have the same here, that sometimes you are more busy to walk around and make sure that it's not going.
Winter time. Yeah. I'm on the job making sure that people turn things off. Yeah, we'll often go like a week with no sun. Yeah, not quite as bad as Greenland, but yeah. So actually, that's talking about dynamic control systems. Can DEIF also work with, say, advanced grid interaction functions like virtual power plants?
We can. The high selling platform, Cameron touched on it. It's called the 150, where we say this one shoe fits all, but again, where you put in or install multiple controllers. This one have the opportunity to, you can say, take in simple signals from maybe an aggregator or something like that from the outside, and then change the mode. We have a lot of standard mode functionalities inside our products, like fixed power, mains power export, peak shaping, and all of this. So you can actually, you can say from an aggregator, you can start to say, now I want to export so and so much power. So that is that platform. But we also know, and we see that another topic of the world at the moment, cybersecurity, how to protect your critical infrastructure and so on. So we the last 3 years, we have actually launched a new platform which have a much higher, you can say, the processor inside is a quad core, something crazy, which can actually handle a lot of these functionalities like cybersecurity and other things. But it's also able to cope with, if you have some AI algorithms or other things you can push to it, it can actually handle these kind of things as well.
What about, I don't know if you're familiar with the term FCAS, frequency control and ancillary services?
I'm fully aware of that here in Australia, and the 5 meg limit and so on. That we can also do. I think what we see, again, I'm coming from Europe, so that is maybe where I have my biggest knowledge. But we see a big growth in small C&I businesses. It can be a factory, whatever, investing in batteries. And some of them actually find out that when they invest in the battery, it's maybe with the mindset that they need to store their own PV and then use that later. But many actually find out that when they can support ancillary services, like in Europe, we have these FCR, FFR, that is fast frequency response, frequency curtailment reserves, and so on. If they can go in and support these things and sell that, maybe like a service, maybe half of the battery, let's call it that they are selling that to a trading company, then they see a complete other business case. So we are into that, you can say, market, and I believe it's a little bit similar to the things here. Virtual power plant is of course one of the things you can talk about, but then ancillary services, arbitrage of your battery and so on. We have some functionalities to that. Where we see a challenge is that it's not always generic what they are asking. So we are not able to make one function and one shoe fits all for that, because a trading company having an aggregator or API interface in Belgium might be different from the one in Poland, and will probably also be different for the one in Australia. So here we need a certain level of customization for each area. I'm not saying for each project, but the services are sometimes different. And it is everything from a simple digital output, and then we need to do something, to a prediction, or we have a full, you can say, correspondence with the utility company or grid operator of what they need. So it's an interesting area, and we definitely are a part of it. But we also see that there's much more money in it, and there's much more, you can say, focus on these interfaces and how it operates than the what I like is the microgrid kind of make a microgrid work in a perfect way. The other one is just a bonus. But the challenge right now is that the bonus is starting to be so big that you can say the microgrid operation sometimes are the second thing that you are looking into.
So you're not just a hardware company, you're a software company as well.
Isn't everybody becoming that?
Yeah. Wow. Where do I go with this? AI, it keeps coming into everything, really. For instance, things like solar forecasting.
Yeah.
That would be obviously through a third party, providing with signals. You can respond to those and then make decisions about how to use the battery.
Yes.
Yeah.
Yeah, I don't know how much AI there is in it, but you can say we have for decades also done wind parks where you have a kind of 24-hour, 36 hours time slot where you actually predict that tomorrow at 12 we can generate so and so much power. You send that to the grid operator or the utility company, and then they send an answer back and say, yeah, you maybe should do 10% less than what you can do, and then you actually are obliged to deliver that power. If you don't do, you get a penalty. So that mechanism, you can say, we have worked with that for the last 10 years with wind. And it's no different if you look at the solar thing. And here, of course, we see that the penalties are sometimes crazy, much higher than what you actually get for the production. So here batteries are also coming in. If you look at AI, then I think it's more like if you can bring in the conditions of your site or other things, maybe predictive maintenance or other things, when will it be smart to do that? Also maybe related to a weather forecast or other things. The most crazy system I have seen is actually in US, where there is a lot of data acquisition. Then they send these data up to a kind of server, and on these servers there are some I call them robots, but it's an AI thing, and then 3 of these robots compete with each other to actually, based on the data they have, give the best output, and then they generate an algorithm which is then downloaded or sent to the plant controller, and then you monitor if that prediction is kept,
which is the good robot.
And and if it is, then it keeps on running because it was the best. If it isn't, then you actually make another turn of competition, you can call it. It's at a level where I start to think, whoa, where are we going to be in that equation? I have seen it working with AI and so on, but again, where we use AI inside DEIF is everything from doing the software part. Actually, our own R&D, they start to use it. Also scary sometimes, because doing software is a lot of if-else repeating things, and that is actually where AI is quite good. But also collecting, of course, information and so on. So what we have tried to do in the company is more to make sure that our platforms are ready to be able to handle the data and actually work with AI. And I believe we have just scratched the surface as of now. Yeah,
I can see you're the enabling technology that takes in that information from another source. Yeah. Wow. Okay, we covered a lot of territory.
Absolutely.
Yeah. So let's move on to compliance, safety, global standards. I mean, DEIF operates globally. So how do you ensure that you meet all of those standards, the IEC, UL, ISOs, etc.?
I very often say this is the non-fun part of the of the business, because I feel we are spending a crazy amount of time fulfilling these requirements or whatever is needed in the different areas without adding any value to the product. I fully understand that we need to be safe. We need to fulfill that there are different, you can say, functionalities towards the grid. It can be simple things like disconnecting if you have a fail in your system, to again supporting the grid when it's needed. And here we also see a big challenge in what is the controller system going to do and what is the power converter, because the trend is going in a direction where everything is a power converter connected, because we also see DC bus bars coming and so on. Everything is converted at the moment. But what we do at DEIF is, of course, that we have been forced to follow this and meet all the grid codes for our customers the last 30 years. And we do the same today. And as I said before, we are moving into actually our own power converter, where it's another, I would say, set of rules that we are very known about the thermal part, like the rotating machines like diesel generators. We have pretty much all the grid codes needed. In that area, there is these ANSI codes, which you can say if you cover more or less all of them, then you can also go in and say, okay, in this area we need ANSI code 51, N or 49 or whatever, and then you pretty much have a controller that's able to cover most of it. But the other part is challenging. And I know also when I talk to my dear friends who are selling power converters out of China, different brands, they start to be a little shaky when you mention the word grid codes or other things. So, and it's not an easy task. But I would say with the size that DEIF is and our history, then we will definitely support it. And we are also supporting most of the things here in Australia. So Cameron, he can go and sell if he wants. But it's every day changing. And suddenly Cameron, he talks to another utility guy in Brisbane or whatever, and then something new pops up. We need to find out, are we compliant or not? So yeah, that's how we look at it.
I like your analogy, the non-fun part. Yeah, I can see that. It's almost like there's an emergency every time there's a change.
Exactly.
So here in Australia, we have a grid code for 777 Part 2 for inverter systems connecting to the grid, but we also have CCIP US based on IEEE 2030.5, but with variants across different DNSPs, different network operators, and we soon will be getting dynamic envelope operating requirements, which might be what I think they're calling it enhanced CCIP AUS. There's another new challenge. So not just controlling inverters and PV inverters and so EV chargers, but also controlling energy storage as well. Yeah. So I can see, it's definitely the non-fun part. And that's a roadblock to selling the product because,
exactly.
If it can't do that, they don't want it.
That is probably also why you can say we get a little scared. Not only the Chinese do, but we also get a little scared sometimes because we know it could be a roadblock. It's not just a small stone on the road. It's actually sometimes, even though you have really made a great product, then you actually comply with all the stuff, then there might be 20 tests that you need to prove that you can do. And that can take half a year. and then when you're then done, then there is an authority who needs to approve it. And if they are busy or you meet the wrong guy there, then it can take another half year to get the signature. So that yeah.
Yeah. I mean, I think Australia's suffering the just too much solar problem at the moment. I mean, we've got 40% of homes with rooftop solar.
Yeah.
Rooftop solar is enormous, like 20 gigawatts.
Whoa.
It's twice as big as utility solar, which is the wrong way around, really. And it's mostly has been uncontrolled. Just whenever the sun shines, off we go.
Yeah. I actually saw some stats last year when I came to Australia where Denmark and Australia is actually quite similar in you can say how much sustainable power you produce compared to other things. So I think the challenges in each of our countries are quite similar. But of course there are some geographical things that's completely different. But that is maybe also where we from not only DEIF point of view, but from Denmark point of view, try to do a difference, because we have a lot of wind power. We start to have a lot of sun, and many days a year we are 100% green. But that is still supported from big thermal machines in Germany and other places to keep the frequency or other things. So yeah, that's it. There are some similarities for sure.
Yeah. In many ways, Australia's a bit like Europe. It's got lots of different systems that are all linked together with different rules in each state.
Yeah. Yes. I don't know if you have a Germany in Australia, which are, you can say, the ones dictating a little bit what the others should do.
Maybe we'll blame Queensland for that. Wow, we've been talking for ages. I just realised the time.
Yeah, sorry.
But that's okay. Maybe we'll just sort of kind of wrap it up a little bit here. So let's put our crystal balls on. What are you looking in the future for DEIF in terms of other energy control systems? Or what about hydrogen? I know energy storage, you're talking about having your own product as well. Tell me a bit about that. Yeah,
you can say when you look at history, there is a war, a famous movie, I can't remember the name of it, AC versus DC voltage.
War of the currents.
Yeah, exactly. And we can see that is changing again. If not all our infrastructure more or less was based on AC, then I'm pretty sure DC would win as it is of today. I also sometimes think about in your household, what AC do you really need? What we have seen from DEIF point of view is, of course, that many of our products and also our DNA and history have been based on AC busbar. And with the DC coming more and more in, converters coming more in, you could also be a little provocative and say, if you have DC, how much control do you actually need on top of a DC system? Many things they balance themselves, because you have DC converters to say, okay, when do we charge the battery? When do we discharge it? You balance much more things in the power layer instead of doing on the control layer. And that is why you can say we from DEIF point of view have been looking into where should we be in 3, 5, 10 years from now. And one of the things we have decided is to go into to power converters. We are focusing a lot on marine. Again, a little bit our history. We started in marine. Why not do that again? But one of the reasons why we also focus on marine is that there are a lot of clear agreements in the industry there is, you can say again, a target to be neutral by 2050. There was a big meeting in London last week where people should vote from all over the world to actually go in that direction. There is a guy west in US maybe not agreeing on all of it, so he made a little, you can say, disturbance in these plans. But beside that, then marine is actually a quite nice industry to target, because there are clear goals, and the industry, our customers within the industry follow that one. So what we also have decided is actually to go for a technology called silicon carbide. And silicon carbide is, you can say, the new boy in class from IGBTs and so on, where it can do much higher switching frequency and other things. But what it brings is a 2 to 3% increase of efficiency. And that makes what I see as a game changer in ways that if you have a battery system out here, and every time you charge a kilowatt to the battery and you discharge it again, that you lose 6-8% power, and it's heat up in the air. If you can reduce that to 1-3%, then over the lifetime of the system, it's actually a lot of power, and by the end of the day, a lot of money. And also on ships, the volume of a silicon carbide system and the weight of it is maybe 1/3 of an IGBT system, because you don't need all the filters, other things, they are built in. So in that perspective, we actually see a great benefit of bringing this technology into energy sector, and starting with the marine, of course. But we will also be able to deliver for land, and of course it's a natural step in the same time. So that is one of the big things we do. And as I said, one of the reasons for this is, of course, that a lot of things are moving in the direction that power converters are more and more intelligent. We also touched a little bit about droop curves before and so on. There's many functionalities built in to the power converters nowadays. And we see that portion of functionality is then removed from our core, which were the power management controllers that normally was on top of the asset. So that is, you can say, where we are going. But we also see that a lot more flexibility need to be brought into to microgrids, whenever it's a ship, which is a small microgrid, or it's a land-based, cybersecurity, other things. So we also see that the need of controllers which are able not only to control a ECU, genset, CAN communication, it now needs to bring in so many other aspects or signals from the world outside, and we just try to do our best to make sure that we have the platform, hardware, software-wise, that's able to meet these requirements. If it's DEIF by the end of the day doing the software, we don't care actually. If you would like to sit a Sunday and do some magic on a PLC that is inside a DEIF product, feel free to do that. So we actually just try to make the flexibility, and that is maybe not so much what we have done earlier at DEIF, because earlier at DEIF I would not say we told our customers we know best, but it was, again, whenever you needed a full approval of a system and so on, that portion of magic you want to do yourself was more difficult to say it will not disturb the rest of the system that was approved. But that things are changing, of course. So yeah, it's exciting future for sure. And again, I love this, you can say, technology things, but also actually returning to what we talked about in the beginning, coming here, understanding what challenges Cameron he's facing with his customers, talking to you about what are you, you can say, looking at to support just a group of houses here and so on. That helps me a lot to also bring back and say which direction we should go. So, yeah.
Yeah, cool. Hey, you said something at the beginning of my question, which was about the war of the war of the currents, and you were saying if it was happening now that DC would win, and I sort of thought, hang on, what about motors? I've got air conditioners, I've got a heat pump, I've got a water pump, and I started thinking, hang on, they all convert AC to DC and then reinvert it anyway.
Yeah. Exactly.
The AC is just a fuel source.
It is. So I'm not right all the time for sure. My wife also tells me that, but it is interesting actually to think about what was in the electricity or energy sector, the discussions hundreds of years ago, and then where are we today? That's really it's a funny thing to look into.
And DEIF is right at the forefront of that in terms of having to solve those problems.
Yeah.
Yeah. Well, Jacob, thank you very much for coming on my show today.
My pleasure.
It's been a really fascinating discussion, and I think I'll have to take you on a little tour around the facility here so you can come up with some suggestions.
To do that. Yeah. You have a lot of toys here.
I have a lot of toys. Yeah. Oh, well,
okay.
Thanks very much.
Thank you so much, Glenn.
Right. We're out. Okay. Excellent. Wow. I think that's the longest interview I've ever done.